Hi folks, this is Nat, and this is going to be your video lesson on how to calculate the area and perimeter of composite shapes. So what is a composite shape? A composite shape is any shape that is made up of other shapes. We learned in a previous video lesson how to calculate the area and perimeter of some simple shapes like rectangles and triangles, and a composite shape could pretty much be anything else. If you know how to calculate the area of a rectangle and you know how to calculate the area of a triangle, you can calculate the area of any other polygon that you find, provided you know enough information about it. So here's a quick example. This is a weird looking shape, and if we count the sides, we'd actually discover that it's a pentagon. It has 5 sides. And we might initially look at this and think, oh man, this is going to be really difficult to figure the area and perimeter of. But if we start dividing this thing up, we'll discover that it's actually made of not one big shape, but lots of little shapes. So here I've added some lines. And what we can see is that this is not nearly as complex as it looks. It's one big rectangle, what appears to be maybe a square, really close to being a square rectangle, and then one triangle. So it's not a particularly complex thing. If I knew the area of each individual component, I could get the area of the whole thing. And that's the general idea of composite shapes. So let's kind of put that to work. Here are some measurements for the different sides of this pentagon. And I already know most of what I need to know to calculate both the area and the perimeter. One of the things that we want to do, generally speaking, is kind of generalize the information we have to maybe places where we think we don't have information. So, for example, this is a rectangle that I'm looking at right here. And I know that rectangles have opposite sides equal. So even though I haven't filled in the opposite side of the rectangle, I know that that's going to have a distance of 4, just like the other side. Similarly, I could say that this square is a rectangle, so this side up here is going to be a 3, and maybe I need that, maybe I don't. And then the other thing is I can say, because this total length here is 7, that must be the same as the total length here. And because the 3 already takes up a part of the 7, what's left over for this triangle down here is 4. So as I kind of begin thinking about how I'm going to calculate the area of this, I'm filling in the sides that I might need to know. Now there's 2 ways to approach composite area. We'll come to perimeter in a second. There's pretty much only one way to do that. But there's 2 ways to approach composite area. The first is to pursue an adding strategy, which is to figure out all the little pieces and add them up. And I'll demonstrate that one first. Let's say I want, again, the area of this. Well, to find the area of the whole shape, I need the area of the individual components. So the area of this rectangle here is going to be 4 times 7, the length times the width, or the base times the height. That's 28. And the area of this square here is going to be 3 times 3, that's 9, same deal. The area of this triangle is going to be half of 3 times 4. So remember, we always have the areas of the triangle, so base times height divided by 2, or times a half. So 3 times 4, the base times the height, because I'm going off of this 90-degree angle, is 12. And then I half that and get 6. So in an additive strategy, what I'm going to do is take those individual areas, 28, 9, and 6, and I'm going to add those up together to get my total area for the entire thing, which in this case is going to be 43. So 43 square units, or whatever we were measuring in. The alternative to an additive strategy is going to be what's called a subtracting strategy. And it should theoretically get you the same answer, it's just a different way of going about it. In a subtracting strategy, what we do is we imagine the shape we see as a piece of a bigger shape, either probably a rectangle or a triangle, something very easy to calculate the area of. So for example, in this case, I could imagine the full rectangle that extends all the way around this shape. And the only piece of that little rectangle that I don't want is going to be this little chunk down here at the bottom. So I could calculate the area of that full rectangle and subtract the area of that very small piece in the corner. So let's look at how that might be, or how that might go. First of all, I see that the length of this side is a combination of 4 and 3. So this giant rectangle has a length or width of 7, and then over here, again, 7. So I know that the entire rectangle is going to be 49 square units. And all I have to do is figure out the area of this triangle again down here in the corner, and I can remove that from 49. In this case, that triangle has a base of 4, and I'm kind of carrying that down from here. And it has a height of 3, which I'm bringing over from the opposite side as well. Again, area of a triangle, base times height, 4 times 3 is 12, and half that, so it's 6. So I need to remove that 6, because that's not part of the area of the actual thing I want. So 49 minus 6 equals 43. And so you can see with either the adding strategy or the subtracting strategy, I get the same answer, 43 square units. So both of those strategies are equally good, and you may get to decide which one you like better, or you may find yourself with enough information that you have to use one or the other. But it's good to have that sort of general sense of how you can approach these problems. So let's take a minute to look at some common composite shapes. The first one we're going to take a look at is the idea of a parallelogram. This might also be a rhombus, but a parallelogram has its own formula, but you don't actually need to know it because it's basically the idea of composite shapes again. So let's think about how we could divide this parallelogram up into easier shapes. For example, I could take it and just draw a rectangle in the middle from the corners. And now I see that I have one rectangle and 2 triangles. It's nice to know that I love right triangles, and you should too, because right triangles you don't need to know any fancy information about. You can just know their height and their base. Pretty easy. The other thing you can do with right triangles is imagine that you move them around. You don't have to think of this parallelogram as a parallelogram even. Let's say, for example, that we imagine taking this triangle off and attaching it right over here, so that what we end up with is actually not so much a parallelogram, but a rectangle with that shape. So you can imagine, if it helps you, moving pieces of a shape around to fill empty spaces somewhere else. That might help me, for example, if I knew in the case of this parallelogram that it had a base of 6 and a height of 3. If I remove that triangle on the side and place it on the opposite side, well, now I have basically a rectangle with a base of 6 and a height of 3. So I discover that the area of this parallelogram is just 6 times 3. So it can make life really easy. Another really common composite shape is going to be a trapezoid. And again, a trapezoid has its own area formula, but it's just based on the idea of splitting it into chunks. So if I look at the trapezoid again, I can turn it into 2 triangles and 1 rectangle. And if I know the information about those, I can find its area. Let's say, for example, that I know that this trapezoid has a height of 4, its top is 6, and its bottom is 11. Again, if I imagine dividing this thing up, the first thing I'm probably going to do is think of it as a rectangle with 2 triangles attached. Now it becomes a lot easier to deal with. That rectangle in the center is going to have a 4 times 6, 24 square unit area. And then the triangles on the side are going to be everything else. We can imagine pulling those triangles off and actually putting them together as a single triangle, which I still know the height of. It had a height of 4, and I can very easily figure the base of, because I know that the rectangle had a base of 6, and the triangle accounts for all the remainder of this 11. So 11 minus 6 means that the remaining base of that triangle must have been a 5. So now I can calculate the area of that triangle. It has a height of 4, base of 5, so it has an area of 20, which I'll have because it's a triangle. So it has an area of 10. So using that whole additive method idea, I can say this 24 for the rectangle and this 10 for the triangle is going to mean that I have a total area for the trapezoid of 34. So as you approach composite shapes, the super important thing to be thinking about is what information you have and how you can use it creatively to figure out the information you need. Here's one more example, and we'll calculate the area of this composite shape. So again, it might look complex to start with, but it's actually just made up of 4 little shapes. And we have enough information to do a lot with this. So let's start by transferring the information we have to all the places where we might want information. So I see that this space here is a 2. So this is going to be a 2 as well across from it. Same thing over here, this one will be a 2. So now for each of my triangles, which happen to be right triangles, I have both the base and the height for those. And if I look over here, there's an empty space. That's going to be a combination of this 2 and whatever's left over from that 7 to make up that full side. So 7 minus 2 is going to be 5, so it's going to have a distance of 5, which I may or may not need. And I think I'm going to do an additive approach here because a subtractive approach doesn't really make much sense because the shapes that I would have to remove to do subtraction are pretty complex in themselves, so it just doesn't seem worthwhile in this case. Maybe we could do it, but it's probably not worth it. Let's start by figuring out the area of this rectangle up here on top. I see a base of 5 and a height of 7, or a base of 7, height of 5, doesn't really matter. So 7 times 5 is going to make 35 for this rectangle. This is a square down here. It's going to be 2 times 2, so it has an area of 4. Then we have these triangles here, which are both base 2, height 2, base 2, height 2. So they're going to have the same area. They seem to be identical triangles, whether they look that way or not. So base times height divided by 2. 2 times 2 is 4, and if I have that, it is going to be 2 again. So each of these is going to have an area of 2, meaning my entire area for the whole thing is going to be 35 plus 2 plus 2 plus 4. Making my area for the entire thing, I believe, 43. So hopefully that gives you a sense of how you can use composite area calculations. Perimeter is not really a whole lot different. You're just trying to specifically find all the sides on the outside of the shape, and once you have those, you can add them up. And here are your practice problems for the lesson. You've got 2 composite shapes to sort of break up and figure out. Find the area and perimeter for both, please. And that is pretty much it. Good luck.